बाबू şöyle ha.
Okay, welcome back. And finally, we received the network, good network, optical fiber. Let's repair this inverter. How to repair expert VM 1.2 kilowatt rated power 1200 volt ampere and 1200 watts power factor 1. Okay, we have fault or issue in solar section. Okay, let's check. Okay, set down. Let's check. Okay, first I need to connect this inverter with battery. This is a 12-volt system. MPPT charge controller we have in this device. Okay, turn on battery. Okay, now I am providing. Already no any issue we have in this inverter. We have just fault and solar charge controller. Okay, when I provide here a PV voltages before the sense of solar section have a consumption on PV side, so that's mean in my knowledge solar charge controller MOSFET is shorted. Okay, now I am providing, let's check. This is my power supply, bench power supply. Okay, and I provide here PV voltages from this power supply. Now I am increasing the voltages. Let's check. Now, any solar icon we have. Okay, and this battery connection is connected with this battery. So check here, 14 volts, 13 point some 13.18. Okay, so that's mean here we have 4.1789 amperes consumption. So that's mean we have short MOSFETs per solar charge controller. Let's check. Okay, first I need to remove the PV connection. And after that remove the battery connection. And remove the top core first. Disconnect the strip. First we need to have an LCD at the solar icon, and after that microcontroller can provide a pulse wide modulation to charge the battery. Let's remove it's okay. Little I need to set my smartphone here. It's okay. Keep all the screws in one box for this inverter. So this is all the screws of this inverter I am removing. Six nut driver. No man, come. Oh, seeing that. Aji, دخل كده بس زبده ټلیفون کومه ښه اوس نه کېږي ښه هاي چې کړي وې چې مزله سوا بس ما چې کړي ده نه ان کېږي که نه زبده ټلیفون کومه ښه اوس دا شته کار دی که نه چې دا وکړو ښه دی دا زبده ټلیفون کوم دا نمبر دی که نه زبده کار وکړم ښه دا اوس بېغمه شئ دنیا په څه ما ټیک کړي دي ښه اول سر رابن پہ sorry for that, but I had customer and I received lithium battery for repairing. Okay, now just need to check grid neutral output. Okay, I not received screw on this PCB, complete screw I not received. Grid neutral, sorry, output neutral and output line, and here we have grid line, and here we have grid neutral, cooling fan strips. Now remove all the screws. Here we have one more. Check. I think we have more screws. Oh, here we have one. For this model you need to remove one cooling fan because the manufacturer not clean the PCB properly. I will show you little bit. Now you can remove easily. Okay, little comments. Kairan, plug it in. AC power source. Ivan Lazari. Said hi, how are you? And Kairan, plug it in. I don't understand. Cannot understand what you want to say. In electronics language, mention please. Okay, here we have a charging MOSFET. Sorry, I touch the smartphone. This is the solar charge controller complete components. We have inductor, okay, and here we have n-channel MOSFETs for step down, okay. This is just the buck converter. We cannot call MPPT, okay, because they cannot trace the maximum power point tracking. They just step down in here. Check. Oh, some person already worked on this device for this fault, because look at, they remove one MOSFET from here. Oh, this means someone try on this. Okay, let's check the MOSFETs first. How we can check the MOSFETs? Use here for step down converter. Okay, this is the diode, because here we have P, and N, again P, N. This is the one MOSFET pin 1 gate, 2 drain, a third source. Okay, keep the negative on pin 2 drain and positive on pin 3 source. Okay, this MOSFET is okay. Internal resistance is okay. And here we have another 2 MOSFETs. So this is the MOSFET pin 1. This is gate, pin 1 gate, 2 drain, 3 source. Keep the negative again on pin 2 drain and positive on pin 3 source. We have true resistance for these MOSFETs. Then Y, we check. Here we have PV voltages. First check. This is the PV input positive, okay, and this is the battery positive, so we need to check, okay, and this is the PV negative, and this is the battery negative. No any continuity we have directly connected with battery. Okay, let's more check. I'm not the expert of charge controller, because we have multiple types of charging controllers and solar hybrid inverters, but let's try to repair in live stream. Okay, but why we have direct current before the pulse wide modulation from microcontroller? Here we have one HCPL A350 and A3120 MOSFET gate driver IC, Optocoupler. Okay, how we can check pin 1, 2, 3, 4, 5. We need to keep the positive on pin 5 and negative on pin 8 to check first the internal resistance of this optocoupler. First of all, the HCPL optocoupler gate driver GND and VCC already we have a short circuit. So first I need to little zoom. This is the HCPL. Here we have some numbers: HCPL 8350, 8350, and 3150, 3120, and a TLV 352 and TLP 350. The same pin configuration we have: pin 1, pin 2, pin 3, pin 4, pin 2 for command anode, and pin 3 for cathode. This pin is not connected, okay. And pin number 5 we have for this optocoupler negative, and pin 8 we have positive VCC. So we need to check like this. We need to keep on pin 5 positive and pin 8 negative. We have complete short circuit. So first of all, we need to remove this HCPL from here. And how you can remove easily? I am also removing with this method. Otherwise, if you are removing with your method, you can remove with your method. But I am removing without hot air, with some soldering knowledge, some soldering and desoldering knowledge. And what is the soldering and desoldering knowledge? Okay, provide here heat at a time to this 8 pin, melt all the solder and easily remove the component. Okay, now I need to remove the extra solder from here. Okay, now I need to clean this area. This is the glue, very hard. We cannot remove this. We can damage the PCB track, so no need to clean this area because the manufacturer apply the glue here. That's okay. Now you need to check the PCB continuity. Maybe we have a short circuit in our PCB, or you need to check the component, but this is the easy way to check the PCB continuity. Okay, no any short continuity we have in our PCB. So let's separate these pins first. Okay, and now here I need to check dot pin 1, 2, 3, 4, and this is the pin 5, and this is the pin 8. We have a completely short circuit. Here I need to check with the front of camera. Just check, man. The optocoupler is completely short. We need to have 0.6 something continuity per internal resistance of this component. So first of all, we need to replace this optocoupler. The HCPL and 8350, but the good number for this I am also received from manufacturer 8350V. Okay, and how we can check. If you want, just comment. I check this. Okay, in the middle, we need to check. But later, some people are know about this. How we can check. Later we can check. But I am installing here, and I purchase pull out. So first I need to check this, and before this we can check this with multimeter. And how we can check with multimeter? Pin 1. Okay, so here we have pin 5 negative. First of all, we need to have here 0.6 something continuity per internal resistance, like this. Okay, and after that we need to check the output. The pin 6 and 7 is output of this optocoupler. So here we need to have some continuity. Okay, 0.537. And when we keep the negative on pin 8, so in this time we need to have more than continuity from this pin. Let's check. We have 0.882. Okay, so with the multimeter knowledge we have the true optocoupler, and after that we need to check the anode and cathode continuity. So the pin 2, you need to keep the positive on pin 2. Okay, little hard, but I need to show you. Oh man, I can hold. Just little time required. This is the pin 2, and this is the pin 3. 1.3 to 1.4 continuity we need to have for this optocoupler. Let's okay. And now how we can check 100%? Sometime we have true continuity with multimeter, but in the real time the multimeter is not, the optocoupler is not working. So apply here 14 volts. Okay, and I will share you the data of this tester of HCPL 8350 and 3150 and 3120. Apply here 14 volts, minimum 14 volts. Okay, and you can apply here 30 volts. So first we need to have the blue light, because the positive already provided to this blue light LED, and the negative is providing now the optocoupler, because the optocoupler are not receiving the input command to provide positive on pin 6 and pin 7. So how we can check and how we can provide a command? Temporary, you need to have 1.5 volt battery. Okay, and connect here 47 ohm resistor. I connected 100 ohms and parallel. 50 ohms are 47 ohms you need to connect with this. And after that, okay, I'm just collecting probes right here, voltages. Okay, I get the probes, the temporary, and I need to connect here 1.5 volts battery permanently. Okay, provide 1.5 battery negative with black color wire and positive with red. Okay, and how much voltage is we are receiving on this probes? Just check. Need to learn the basics of electronics components, and after that you can repair every electronics components. We are receiving 1.5 volts. Okay, with 50 ohms resistor. So before the operation, I need to share with you, when here I will apply a voltages per this command. So we need to have turn off this blue LED, and we need to have turn on this red LED. So here I am connecting the positive on pin 2, and I am connecting negative on pin 3. Not working. Why? 14.2 volts. I'm receiving the voltage to have. No, man. This is the important thing to check. Okay, let's check another. Without autocoupler, we cannot glow any light. Okay. Okay, blue. Provide data. Not working. Why, man? Not operating on. I check so many times. No, man. What happened again? Right here. No. Change the props. Why we have issue? In the middle, I need, this is my wish, to provide you a data how we can check the MOSFET or IGBT gate drivers, because this is the popular autocoupler, and this is my wish to provide you a data how we can check with 100% confidence. Oh, my multimeter probes. DPM. Okay. Here I found one. So check this with this method, man. This is the pull out autocoupler, because I not found original and new. Okay, how much voltages we are receiving or not. Let's check again. I'm receiving 1.5 volts on this probes. Then why? The pin 2 is already, I know about positive, and oh, okay, pin 2 positive, not working. Let's check another. Why, man? This is my second time I'm confusing this thing, but before this I provided low voltages per operating, so I found it a flaw, error, but this is the second time to focus on this, and ready this completely to install a battery and install a switch. Provide command. But this is the live stream, don't worry about. Okay, pin 2 and pin 3 not working. Okay, little I am making a series connection with one more battery. Maybe our battery is not able to provide a voltages or command. So here I am connecting in series one more 1.5 volts battery here to increase this voltages, operating voltages, to check why. I think here I found one thing, a broken, one resistor are broken. Okay, we can confirm this later. You had issue with this resistor or another issue we have. Okay, now check. Positive. Now working. Okay, now let's check. When I am providing here a voltages for this autocoupler, the autocoupler are closing the blue light. In the real time they are disconnecting the negative and providing the positive voltages from main power supply. Okay, so for red LED we have already provided negative, and when we provide a command for these two pins, so the autocoupler are disconnecting the negative voltages and they are providing on pin 6 and pin 7 the positive voltages. Now why we fail two times? So let's remove this battery, another battery, and check with one battery, because I also checked just with one battery, but here I found a desolder resistor. So now I am connecting again. Now I connected 100 ohm to resistor, and now I need to check this again. Now working. So the mistake was here, broken resistor, so I need to make this thing properly for next time. And sorry for wasting your time, but this is not my fault. And if you are interested, just comment. I can provide schematics of this tester. And we need to modify it to install in little big thing, and we need to install 1.5 volt battery and proper resistor of 47 ohm, and we need to install here a push button to test. Okay, so we need to modify this tester. I have called, I need to receive. Hello. हेलो जी, सर आप जी ini mi dekat la bagian ada selalu dia pas kemat sama mukora ke ha da caminhão da o mês da caminhão inverter de सर्दी तो पुरुष के लिए पुराना साधन लेके ना भाइयों का निकोरा मोहम्मद अली लिखल है तौर ते लेकिन हो मैं 105 नंबर है ये जे ऐसी कलाम सही ना आ ये ऊपर प्रोनस ते पटु की तड़ले रे ना पदी मातनु नखता है ना तब मखल पदी माने इकराम मटा लिखल है प्रोनस यूपीएस ते तपोस का okay so let's solder this and check we need to work much more on this device okay now here we have a dip package component and here we have assembly how we can convert dip package to SMD package hold in flat tool and bend on 90-degree okay and cut the extra pins again I have called man हाँ ज़बरा जी सही है ज़बरा and cut here okay one more pin now install here install one pin okay is installed I need to boost my soldering station by boosted okay now hold and diffuser must know about the pin 1 here we have pin 1 and this is the pin 1 okay first you need to set on good position it's okay and solder one pin temporary it's okay and check another pins okay so I need to little move here oh man it's okay now check not properly set little I need to move more it's okay now check good okay solder okay other side and now I need to little zoom out here we have more pins it's okay all things are soldered properly now I need to check this and install but we need to install here one more MOSFET it's same MOSFETs okay someone work on this before me 50% to 50% charging or repairing maybe I will repair. Maybe I can't. But do not waste much more time on solar charge controllers because we have 100 types of solar charge controller technologies. Just work on this half bridge topology and this simulated sine wave technology. Okay? If you are working on solar charge controller, you are just wasting your time. Little work on solar charge controller, do not much more. Okay, now I need to provide power supply, but before this I need to install the inductor. Check. Okay, because we found the main component short, so first I need to check. Okay, now I am providing power supply. Just I am checking after that. Okay, increase little power supply. Okay, no any consumption, but okay, decrease the power voltages and turn off the circuit breaker of battery and connect the inductor. Walaikum salam. خيال لك خيال كويس ده موبايل بجيب كده
څنګه طبیعت دې ښه دی؟
خیر دی شکر دی
خیر برابر یې که
خیر
نه؟
دی بیلی کې لګیا مې دي ښه
الله دې خیر کړي الله دې خیر کړي.
تو کې بیا څه نه یې ته به هم نه یم
خام جوړه ته دا دلته چې پروت دی
ها
دا
جی.
ګاډی مې په دې لاره کې زه ځم بره دلته کې دا نیم پرون
ها تاسو ما اوس پیشنټ دی السلام علیکم
ما وی چې دې کمزوری شوی هم یې ځکه خو هغه څه دا جوړه نه بس دا ګاډی غلطي کې ولاړ دی
صحیح دی
زه ګاډی ته ګیم
صحیح دی
دا پولیس والا ټرکټر کې اکثر
صحیح دی صحیح
دا جوړه ته دې یو خاصه ځای کې تیز بس
صحیح دی
نور بالکل صحیح ده مسله یې نشته
صحیح دی صحیح دی تاسو راځئ Okay, now I connected the battery and I'm turning on. Okay, I turned on the battery. Now I am increasing the PV voltages. Okay, no any consumption we have, so why not connect the LCD? Decrease again the power supply voltages for this section. Turn off the battery connection. Okay, and connect the LCD. Check. What we found with this MOSFET and IGBT gate driver component. Okay, turn on the battery. Okay, increase the PV voltages. Okay, sense I think turn on. Okay, now we have okay, sorry for upside down view. Now we have a solar icon for this and no any consumption now we have. Okay, and when I will found a consumption from PV side. Okay, I found, and now check. PV voltage is 13 point. Okay, PV 1M. Why? Okay, little I need to increase more PV voltages to 40 volts because this is the 12 volt system, and here I need turn on one more. Not properly holding the amps. MC fire security and activation. It looks like you are making a fire alarm panel. No man. I am repairing the solar hybrid inverter. Again, the charging is disappear. The charging appears is disappear for little time. I found, and now we need to check again the component why we have. Okay, so decrease the PV voltages, turn off the battery, again turn on, and increase again the power supply per PV voltages. Okay, inverter sends the PV. $41 0 amps. But the inverter are still not working. वालेकुम सलाम।
وشنا څنګه
خیر دی
شاید بای
जी जी
ما کلم نه دا نه وړي
ها
ما تاسو چې کړی دی کنه
نه مې چې کړلا دلته کې زه یوازې یم دلته دې شي باندې بل څوک پوهېږي نه چې دومره کار دی که نه
ها
چې
نو
تاسو دغه دریو کې وګورئ دې کې دی ستاسو انورټر دې کې وګورئ دغه
دا
ها.
هیڅ کلم
ها ټایم راکړئ که نه شي اوس به کالام ته ځئ بیا
زه اوس خو زه روان یم کلام ته دا کمیشنر اوس دغه دی
ها
شی خراب شوی کنه هغه وایي تاسو ولته دغه کوي نو
دا بیګا خراب شوی دی
نه د دې تقریبا یو څلور پنځه ورځې کېږي چې دې چارجینګ نه ایسټو کنه بیټرۍ کې لکه چارج کوي
ها صحیح ده زه به وګورم که نه تاسو سره به رابطه وکړم دغه نمبر پې چې دی دا پې چالو
دا
نمبر
زما
دی
نمبر دی.
صحیح ده زه به ستاسو سره رابطه وکړم ښه
صحیح.
ټیک شو جي
نو ټیک دی ته رابطه وکړه نو تیار کړه څه مسله ده صحیح
زه
ده
به ستاسو سره رابطه
او
وکړم
بیا څونه ستاسو دغه کېږي که نه هغه به دلته کس تاسو دغه
اسانه ده
دغه وچت
اسانه ده
ټیک دی جي
ها
صحیح ده مهرباني ستاسو نمبر هم ما را کړی
ټیک ده جي ټیک
زه به
ده
هم رابطه وکړم
صحیح ده جي اواز سره بند okay now again check the auto coupler why pin 1 2 3 4 5 okay and check we have true resistance for this okay from negative 0.505 and from positive we need to have more than resistance ah ha 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 now the auto coupler short from positive. We have big issue in this inverter with solar charge controller because now I install this MOSFET and IGBT gate driver 8350V. In little time again they shorted. So we need to work on gate drive resistors, and I need to focus on operating voltages. How much voltages we have for this operating system. So let's connect this with battery. Provide PV voltages. Increase the PV voltages to sense. Okay. Check, but the inverter not sense the PV sense, but we have a buzzer or alarm and a top core. It's okay. Now check how much voltages we are receiving. Okay, connect the charger with smartphone, man. I have little charge on my smartphone. Connect this first. It's okay. How much voltages we have on pin 5 and pin 5 GND and pin 8 VCC. Now no any voltages or 1.8 because the pin 8 and pin 6 is shorted together, so decrease the PV voltages and disconnect the battery and remove the component first. Okay, now we can use our hot air gun because I install a quality solder. We can melt this solder with low temperature. Okay. Check continuity. We have short continuity in board, or we have short continuity in our autocoupler. No any short continuity we have in this PCB. And why? Before this we checked the continuity with this pin 8 to pin 6, and now we have short circuit. Before this I remove another shorted MOSFET and IGBT gate driver 8350V. So now check the voltages, provide again the battery voltages and increase the PV voltages to sense. And now check the operating voltages. How much voltages here we have for operating this HCPL? 3.9. No, the required voltages is 12.5. Oh, 3.8. What is this? It's not the required voltages to operate this component. No. Okay, so we need first to provide here 12.5 voltages, but depending on this components and the person already work on this device, so we can last our time. If we have here a true copy of this board, I have one and 24 volts. I need to check this because we cannot repair this and we cannot keep remember in mind because we have 100 types of solar charge controller. Just check a man who replaces everything without knowledge. Here I have another inverter of this brand, but I have an 24 volts and I received the damaged microcontroller and I order and I received the microcontroller of this inverter, and we will repair this inverter and for another live stream. I am just checking if we have same PCB. Okay, zoom out first. This is another same brand and here we have just 3150 HCPL. Okay. They removed the Zener diode from here. And what about schematics? I think this is the same PCB, and we can copy the components value from this PCB. So possible, but do not waste on solar charge controllers. Okay, remember this thing. Just learn the topologies, the push-pull and half-bridge and flyback charging topologies, and simulated sine wave, how you need to check the negative drive about IGBTs and MOSFETs, and positive drive. This is the extras. Solar charge controllers and off-grid inverters are extras. So I am not more wasting my time. Here we have 3.5, and we need to have here 12.5 volt first to operate here. And what about the microcontroller output pulse wide modulation? Oh, the microcontroller are providing full duty cycles to charge the battery, but here we have not the HCPL 8350 or 3150 to provide here negative or positive for MOSFET gates to charge the battery. So first of all, we need to provide here 12.5 volts. So what's your opinion? Gamer guides. Okay, before you, XDJKL23FN. Hello, how are you, brother? And gamer guides and trusting. Thanks for your knowledge. You're welcome, brother. Thank you for your sweet comment, and thank you for your support. Okay. Now I am just zooming in, and this is required little rest, little work, because this system is very hard. And I'm also repairing the solar hybrid inverters, but not charge controllers and solar hybrid inverters. Okay, so first I need to compare this components with another PCB, and later I will share you the data. And I need to copy this data, because we will receive again in this condition. And now we are lucky we have the same PCB to copy the components value for this PCB. So I need to draw the schematics of this area. Okay, thank you guys. See you next time with next type of repairing. Much more inverters I have for repairing. See you next time. Take care.